Okay, good morning, guys. Today is day 10, and we're almost done the course. Or I should say, we're almost done all the units. Unit 3, you guys are still working on the test, which is due today, 11:59 p.m. And we're on Unit 4, and I think tomorrow is the last day for Unit 4. So you guys are near the end. Let's start with the land acknowledgement before I go any further. We acknowledge we are hosted on the lands of the Mississauga of Anishinaabe and the Haudenosaunee Confederacy and the Wendat. We also recognize enduring presence of all First Nations, Métis, and Inuit people. So, agenda for today. You can see the Unit 3 exponential functions test is due later on today. We're going to talk in Unit 4, we're going to talk about understanding angles, identities, special triangles. And then there's a quiz afterwards. I will post a quiz. I don't know, I don't have a link there. I'll post a quiz. I think the quiz should be showing. If not, I'm going to post it after. But again, what's important is to get this test done today, okay? Also too, you guys, the marks are there. You guys should be able to see your marks, okay? Don't start sending me anything in the text, in the chat about your marks. Your marks are based on everything, like I said, up to last Friday. Does not include, obviously doesn't include the Unit 3 test that's due today, okay? So, so that's something to take a look at. I'll also activate this quiz here. You guys are supposed to fill this out. This quiz, I didn't turn it on yet, but I'll turn it on. After, you're supposed to fill it by 1 o'clock today. Okay. Tomorrow, your midterm marks will be issued. If you want to drop the course and so it doesn't count on your transcripts, you have until July 25th. Okay. Maybe you want to wait and see for some people who, like I say, grade 11, as long as you pass, I feel like you can, the marks that count are grade 12, right? Depending on your programming after grade 12, right? You probably will take advanced functions in grade 12 to get in. But I'm telling you that just because if your mark is maybe say 60 or you want something better, it may not matter that much, right? Because it's your mark in grade 12, just so you know. So don't just say, oh, I'm going to drop it and then take it in August. But then, maybe your mark, maybe something happens in August that all of a sudden your marks aren't as good, right? So I just warning you about that. If you're borderline, I wouldn't drop it. But if you're way below, like 50, maybe you need to think about that, okay? Because, but again, also too, you have to remember the final, there's no exam, but the collimating is worth 30%. That's a big chunk of your mark, 30%, right? So you can do well there, maybe that can boost you up, okay? There's not an exam, obviously. It's like our test, take home, right? There's no exam. Like I said, there's no exam. So all it is just like what we've been doing for the unit test. I give you like a test, a long quiz. You guys do it. That is your collimating, right? And what's a real exam? An exam is that you're not doing it online. That's the real exam. Right now, you're doing your unit test online. But I can't. I don't know what you guys are doing in the background. Really, I don't know, right? Because there's a lot of help probably happening. But on an exam, there's no help. It's just you and the paper, and there's no exam in this class because we're doing everything online, right? So that being said, hopefully you saw your marks. Okay, whatever you see there is the exact same mark that I put on the report card. I didn't bump anything up. It's the exact same. What I do is in the final, your final report card, which is what counts, I could bump things up, possibly depending on if I see, you know, but when I say that, don't think I'll bump it up 10%. That doesn't make any sense. But like maybe, you know, maybe 1 or 2, something like that. Okay. 1 or 2, most likely 2. Okay, 2%. Okay, let's get at it. So we're going to go into, and let me view it as a student. That way I know what you guys can see. So I can see it the way you guys would see it. Okay, so we are going to, not that, we're going into this. So we're looking at understanding angles. That's what we're looking at today. Okay, so we're understanding angles. Yeah, I remember there's no video lesson, is there, right? So I have to, okay, so that's fine. We can go through this. So let's go through the lesson. And let's start. Okay, let me zoom in. So we're understanding angles. We have coterminal and related angles, okay? So this section, you'll look at the different angles that have the same trig ratio, as well as how to learn and how they are related, okay? So different angles that have the same trig ratio. Key is they're different angles, but they have the same trig ratio. Trig ratio would be, say, for example, sine would be opposite over adjacent. Opposite over adjacent is a ratio. So say it was a half. So maybe that's what we're looking at, okay? So first of all, we're looking at, here is when we're looking at from a circle point of view, okay? Right, and this is where we're going to be getting angles from, looking at circles, right? You can see that and this is called a unit circle. A unit circle, well, maybe let's not jump ahead so far. But you'll learn about unit circles in grade 12. But in this circle here, you can see that R is made up of Y and X. If you're using Pythagoras theorem, right? This is a right angle triangle. Okay, and you can see that R is basically X squared, Y squared equals to R squared, right? We know that from Pythagoras theorem, but we also know that if I'm looking at from theta, that theta is equal to, if I'm looking at sine, it's equal to Y over R, because you know Y is opposite and R is hypotenuse, okay? And then if you're looking at cos, it would be X over R, and X is adjacent, right? We know that, and obviously we just said that R is hypotenuse, okay? So then we're looking at like that, so then we know this is opposite over adjacent, okay? So we can see that, right? So that applies anywhere in the circle. If I were to draw the circle, or in this triangle, if I draw this triangle like this, and it's still a right angle triangle, right? And I'm looking at this angle over here, again, this will be my Y, right? That point there is made up of X and Y on that circle, that particular point, just like that particular point. And here's my X, right? And same thing if I drew a right angle triangle like here, if I drew it like this, right? And I'm looking at it from this angle, right? So this again would be my Y, and this again would be my X. And then this is still my R, right? So you can see that in this point here is made up of X and Y, okay? So that's sort of how everything's related to in a circle, okay? So let's go on. So we're looking at the cast rule, okay? The cast rule says that cast stands for cosine, all, sine, and tan. So this tells me, this basically is saying where everything is positive. If I were to draw a right angle triangle and what ratios are positive. In here, if I draw a right angle triangle in here, and I'm looking at from the theta, this is going to be obviously my y and this is my x. Everything in here, if I do sine, theta, cosine, theta, or tan, theta here, everything is positive, okay? Positive values, okay? Positive values. Everything, all these trig ratios are positive. Why? Because I have a positive y, and here I have a positive x, right? Right, you can see it's in this positive zone here, right? It's just like a regular, but now if I were to draw a right angle triangle, I'm gonna use a different color. If I were to draw a right angle triangle over here, right? Here again, this is my R, that's my R, my bad. I should probably do a different color for that R. Okay. So again, this is made up of my X, this is theta, this is my Y. My X here is negative, right? It's a negative quadrant. So if I were to do, and over here, the only thing that's positive is saying sine, and you can see that, right? Because here I'll have here sine theta is equal to positive y over r, right? But everything else, like for example, if I look at my cos theta is made up of a negative x Okay, give me a sec. I don't know why it's not working. A negative x over r. And then tan theta is made up of y over negative r. Well, that means everything here, the only thing that's positive is this. So that's proof that, right? In this quadrant, only my sine's positive, right? And it works for this one too. In this quadrant here, only my tan is positive. Why is that? Because I'll probably have a negative y over a negative x. Two negatives divided by each other gives you a positive, right? And over here, the only thing that's going to be positive is going to be cosine, because only my x is positive here. So if I have my cosine theta would be x, positive x over r, right? So that's how we come up with the cast rule, and basically tells us what ratios are positive. Okay, that's what it says right there. What ratios are positive. So let us scroll down. And here's an example of a ratio given that sine theta, right, is 3 over 5. And what we're saying is yeah, okay. So what we're saying here is you have 3 over 5. Ooh, okay, 3 over 5. So 3 over 5. That's also saying y over r. Okay. When we say 3 over 5, we know our r is 5 because sine theta is made up of opposite, right? It's made up of opposite. Let me write that down. Come on. Let's work here. Come on. Okay. is made up of opposites. And this one here is hypotenuse. And we know hypotenuse is the radius, right? So that's how we get that. So it says here, now the question is determine the exact values of cos and tan. Someone just came in. So the exact values of cos and tan would be, again, would be x over r, tan theta would be y over x. Well, we know from here, right? First of all, if we are given sine theta is equal to 3 over 5, we know this is my, I'll just do like this. I'm just gonna, because it shows the answer, which may be not good. So I'm just gonna just recreate the answer. Okay. Now, here's my right angle. So we know here's R, and here is Y, and here is X. And we're saying that sine theta is equal to 3 over 5. So that means 3 over 5, that means this would have to be 5 because that would be a hypotenuse. And this would be, since this is the opposite, would have to be 3. Well, we need to know what X is. But in order to figure out what X is, you're using Pythagoras theorem, which it shows you right here, right? We know that x squared would equal to 5 squared minus 3 squared, okay? And that's how we get to 4. So now if we know x is 4, we know this is going to be the adjacent, that's the opposite. So now if we want to figure out what is cos, cos is adjacent over hypotenuse. And therefore we know that it's 5, adjacent is 4. So this when we say exact values, we're saying without dividing it out, right? This is exact value, or if we do divide it out, because sometimes we don't want to have repeating decimals. If you divide it out, then it's 0.75, right? We know that. That's pretty much easy there. Okay. And oh, sorry, my bad. That's not 0.75. That's 0.8. Let me erase that. For some reason, my pen is working slow today. It's really annoying. I think the battery's weak. Okay. Okay, I'll do my best with that. And then this one here is 4 over 3, it's 0.75, okay? So that's how you figure out the exact ratios, right? It's either the fraction or it's a decimal, but the decimal is not repeating. If the decimal is not repeating, then you can use it as a decimal. But if it repeats, then keep it as a fraction, okay? So that is that. Let's move on to the next. Here's another example, okay? More of the same, right? Now, what we're given is saying here, for this question here, it says, find, I'm using a different color, I don't like that green anymore. Find both the angle for question 1 between 0 and 360 that have the same value. Okay, so we know this is because you're cast. So question 1, this was question 1. Let me go back up. Question 1 was sine theta is equal to 3 over 5. Okay, so that was the case. So here is, I'm trying to find the angle. So here is 3 over 5. So we're saying that's 3, that's 5, that's 5, that's 3. So basically, we want to find this angle, and we found this angle by using inverse sine over here. Okay, it's 37. So we know this angle now is 37. Okay, so now it's a sine. So in this quadrant, all the trig ratios are the same. So sine theta equals to 3/5. The only other place we can go and find another sign that would be the same would be in the second quadrant where it says S. So over here, we can look at and say, well, if this angle is 37, over here we can draw a right angle triangle and I have this angle 37. Okay. So now it says here between 0 and 360 that have the same value. So if we were to say sine 37 equals the whatever ratio that is, that means also if you go over to this triangle here in this quadrant, this is 37, yes, but we're going from 0 this way. So this angle here is 37, but inside here, from here to here, right? From here to here, I'm going to draw it like that, is equal to 180 minus 37, right? Which equals to 143. So in this area here, sine 37 is the same thing as saying sine 143. They're the same. Okay? They're the same. And you can see that they're the same because if you look at the triangle here, right? Again, you have here 3/5. That's the ratio, right? It'll still be 3/5. Same thing. That would be 3/5. Just how this side is 3/5. Okay? Okay, so find another angle that will have the same cosine ratio as in question 1. Okay, well in question 1, we said the cosine in question 1, cosine was cosine 37. That's what we're talking about. Okay, I'm gonna have to scroll. When I scroll, then it messes up everything. So I'm just gonna have to clear that. And you obviously have the video afterwards, and you also have the screen. So when I scroll and go to here to look at this, first of all, question 1, sine theta is 4/5. Okay, 4/5 we got here, right? Remember the angle is still 37, right? But now we're saying where else we can get the same 4/5. Where else can we get the same 4/5 for cos? Well, it's in this quadrant because this quadrant, all the coses are positive. Since this is a positive, and here all trig ratios are positive. So here must be the other area where it can be positive. So therefore, if this is 37, we have to know that this is 37. But we go this way, right? If we go that way, then the angle is 360 minus 37, which is that. So the angle you're dealing with, right, that's going to give you the same trig ratio as the same cos 37 is equal to 4/5. The other angle that you can get to get 4/5 would be over here, cos 323 would also give you a right angle triangle here of 4/5. Okay, same sort of thing. So let's go on to the next. Here we're doing the same thing. Okay, find both angles 0 and 360, between 0 and 360 for negative, I guess this is sine theta equals to negative 0.7. First of all, what's that angle? We have to find that angle. So if that angle here is, you get the angle there is negative 44. So negative 44, right, is this way, but you're always going from 0 to 360, always going counterclockwise. Therefore, the angle you're dealing with is 316. So if you're dealing with 316, right? So this angle here is what you're dealing with. So here is my right angle triangle. But I also need to figure out where is another right angle triangle that'll give me the same what do you call it, trig ratio, right? Over here, my trig ratio is going to be okay, so my bad. So if I'm dealing with sine, negative sine, so negative sine is going to be here and here, right? Because a positive sign is going to be here in this quadrant. A positive sign is going to be in this quadrant. So the only other areas where sign can be negative is in here and in here. So sign can be negative in here, which we already know that's 316, but we're going to also have a sign that's negative in here. Okay, so what's that angle? Well, if I go, this is going to be 44, we know, but we always look at it from here to here. So what's that angle? It's going to be 180 plus 44, which is equals to 224. So these are my angles, right? Find both angles. So one angle is going to be at 316. The other angle is going to be at 224. That gives me a negative sine theta, negative ratio for sine theta of 0.07. It's going to be here and here. Okay, so it can't be here because it's positive, and it can't be here because it's also positive. So it has to be here and here. Okay. So you can see there, right? We also have that there. Okay. So again, another question, find both angles between 0 and 360 that give you a positive tan theta trig ratio. Positive tan theta is going to be actually here and here. Okay, it's going to be in here and here. So first, you need to know what that angle is in order to draw the angle. So we know that angle. We know that angle is based on the trig ratio. Do inverse sine. That's the angle. So from here to here is 65. And I know from here to here it has to be 65. Okay. So in order to get what that is, you're going to have here 180 plus 65, which is going to equal to 245. So I'm going to have a positive tan ratio, because that's what I have here, over here and over here. So these are my two angles, 65 and 245. Okay. Similar stuff. Okay. Same sort of thing. Now we're going to get into maybe different terms that we need to know. Okay. So we have this term here. Maybe this is a little bit new, but we have this thing called terminal arm. And find the angle to the terminal arm. The terminal arm is this is the angle from here to here. That arm it runs from 0 counterclockwise. So that's the arm there. Okay. So when we say find the reference angle is the angle inside, reference angle is the angle inside the right angle triangle that's created from the reference angle. There's no right angle triangle created over here, but over here there's a right angle triangle. Okay. So here's my right angle triangle, and this is my reference angle, okay? Reference angle is that. Terminal arm is that. Terminal angle is that, okay? So find the reference angle. Well, we know if I were to draw at this point, these are my points. What's the terminal arm? So I have -7, right, on the X and +19 on the Y. So over here, so therefore my Y is 19, my X is 7. And if I'm looking at here, if I want to find the angle, I can just do tan, right? I can just do, say, opposite over adjacent. And here I can find my angle. My angle here is 70. So I know that's 70. So if I know this is 70, I know down here must be 72, right? Because well, I don't need to know down here, right? But if you remember your geometry, these angles here are an opposite. So if that's 70, that side must be 70. But the whole point is we want to find the reference angle. The reference angle is the angle formed in the right angle triangle that's created from the reference arm. So from the terminal arm, okay? So you got that? There you go. So here is the reference angle, and here's the angle that's formed to the terminal arm, which is obviously 70 minus 180, gives you that, okay? Okay, so you have co-terminal angles, angles in standard position that have the same terminal arm. So let's look at this. And they always go counterclockwise. So here, this one here is angle 30, right? And if I go counterclockwise again and go back to here, that would also be considered 390, right? I went past 360, right? So let me just show you another way. If I have a circle here, right? This point there, that angle here that's created there is 0, plus it could also be 360, right? That's what we're saying then, right? I go all the way around, I stay there, but if I go all the way around, it's not just 0, it's also 360, right? That terminal arm was here would be a terminal arm, and that terminal arm turns around, right? Keeps going around, keeps going around, keeps going around, and then goes back to there. Now I'm at the terminal arm is at 0. No, it's at 360, or is it at 0? Same sort of thing here, right? That's what's happening here. Going around, and then it's going past 360. So 360 plus 30 gives you 390. So on, right? That's what we mean by, so it's on the same spot, but then you're just turning around counterclockwise. We'll bring it back to the same terminal arm, okay? So these ones are kind of similar, right? Going around and around and around. So find 3 co-terminal arms of 60. Well, that's kind of easy, right? All I have to do, well, I know 60 is 1. And if I do 360 again to 60, I get 420. And if I do 360 again to 60, I'm going to have 780. That's not hard, right? Also, if I can also go in the other direction too. If I went this way, right, in the counterclockwise direction, that gives me minus 300, right? So this line here, which is the terminal arm, this line here, the terminal arm, could represent multiple angles. Okay, and that is it for this. So let us give me a second. Okay, so we just did that lesson. There's questions on that, worksheet questions. Now let's look at this next lesson, which is talking about quotient identities. Okay, let's look at that. Okay, so let me full screen that, zoom in. So trig identities, okay? So here are trig identities that you need to know, but obviously you don't need to memorize because you can always access this. So these are reciprocal identities. So this one here is called cosecant. So cosecant is the inverse of sine. Secant, okay, theta is the inverse of cosine. Cotangent, which is probably easy to remember, cotangent is the inverse of tan, which is short for tangent. And then tan is made up of, which is probably easy to remember, is made up of sine over cosine. Okay. And this is sort of a Pythagoras thing here. The square root, sine squared plus cosine squared is equal to 1. Okay. So we're not going to prove these. We're not going to prove these, how these exist. Oh, my bad. Oh, okay. So see how these are squared? These are not squared. The same can be said for if these are squared. So cosecant squared is the inverse of sine squared. Secant squared is the inverse of cosine squared. Cotangent squared is the inverse of tan squared. Okay, and then sine squared over cosine squared is equal to tan squared, right? So in this unit here, it's about proving the identity that's in front of you. So in this case here, we have to prove that cosine theta times tan theta divided by sine theta is equal to 1. Okay, so how do we prove that? Is basically using this information that we have above here. This information and then this information. Okay, we know that tan theta is equal to sine theta over cosine theta. So the way you want to do this is when you look at this question here, okay, when you look at this question, you have to prove left side equal to right side, okay? What you want to do to break it down, you always want to break down it so that everything is in terms of cos and sine. Right now here, I have a tan. I don't want to have a tan. I want to get rid of that tan, okay? So if you look over to here, right? We turn that tan into, it's made up of sine. So this tan turns into sine over cosine. So now if we have sine over cosine, we can do some canceling. We can cancel out the cosine. And I'm just left with sine over sine. So sine over sine, anything divided by the same number gives you 1. So now you know left side equal to right side. That's how you prove that. Okay. So this whole little section here is about proving left side equals to right side. Okay. So now you have this one here. Prove that the left side equals to right side. Right. So again, what you want to do is you want to have these and these in terms of sine and cosine. So if I see something like tan squared theta, I have to turn that into in terms of cosine and sine. So if I look at over here, we know that tan squared is also equal to sine squared over cosine squared. Okay, I have that. Okay, and now what I want to do now is so I have +1 here. What I want to do now is basically I want to add these together. The only way to do these together is to have common denominator. Well, the common denominator was going to be cos squared. If I multiply this by cos squared theta, right, on the top, and then cos squared theta at the bottom, I'm going to have my common denominator. Okay. I'm going to have my common denominator. So now I have it over here. So now I can add things together. So I have one common denominator, and I can add the numerator, sine squared plus cosine squared. Well, sine squared plus cosine squared, remember, we know that's equal to 1, right? Because in the trig identity above, right? If I go back, just showing you here. Where am I showing you? It's right here, right? Sine squared plus cosine squared is equal to 1. So I'm just going to bring it back so we can see here, right? So that's equal to 1. So you have 1 over cos squared. Now, if I look at the right side, we know that this is secant squared, or sorry, secant squared. Secant squared is the same as the inverse of cos squared. So now I have both left side, right side equal together. Remember, you have to get this in. You have to get them when you're proving in terms of cos or sine. Okay, so that's what you got there. Give me a second. Okay, so here's another one, another proof question. Okay, you're gonna prove that cos squared x is equal to 1 minus sine squared bracket 1 plus sine squared. When I look at that, remember, you have to get everything in terms of sine, right? But not everything in terms of sine, but that's what we can do. We can reduce it, right? When I look at this looks like difference of squares, right? Difference of squares, right? So what does that mean? Difference of squares. So I have this times that, using FOIL method, that times that times that, and then that times that. 1 times 1 is 1. Doesn't matter, it's not 1 squared, it's just 1. But then negative sine times 1 is negative sine. Negative sine, sorry, 1 times sine is sine. Negative sine times sine is negative sine. And then those two negative sign, the sine and the negative sign cancel out. Then I have here negative, left with negative sine times plus sine. I'm going to have here negative sine squared x, right? That's what I'm going to have. And that's what I get over here. Okay. So this is simplified as much as it can go. But on the right side, I know that cos squared x, if I go back and look at the trig identities, I'm just going to scroll up so I can show you. Scroll up to the trig identities, right? Sine squared x, or sorry, cos squared x or theta is equal to 1 minus sine squared. Well, we just saw that, right? 1 minus sine squared. Here is cos squared x equals to 1 minus sine squared. That means left side equals the right side. Done. Okay, that's what you get. Okay, so that's pretty much okay there. And then here's another proof. Okay, let's do this proof together. Again, you want to get things in terms of sine and cosine. If I look at the left side, I know 1 minus cos squared x, if I play it around with the trig identity, it would equal to sine squared theta, okay? Over here, I have sine theta, cos theta, and I have tan theta. Well, I can turn tan theta into sine theta over cos theta. As a result, I can cancel afterwards. I can cancel this and this, and then I'm just left with sine squared. So now left side equals to right side. Okay. It gets easier after a while, and plus you guys will have access to your trig identity chart. Okay, so this one's a little bit tricky because I have here the power of 6. So we'll keep that there. We won't mess with that. Sine theta to the power of 6. Over here we have this, right? Well, we know that you can apply the exponent to the stuff inside there. Okay, so if it applies to each thing inside there, that's going to be, well, even before we do that, we don't even have to do that. Before even doing that, I can convert this into sine squared theta. Now I have squared on the inside and I have to the power of 3 on the outside. Well, there you go. Bring it on the inside, it becomes sine to the power of 6. Left side equals to right side. Simple. Okay. Now we get into another one. It's important I show you all these different examples because you're going to have so many different variations that you need to get the practice of seeing things differently. Okay, so the left side is sine squared x over 1 cos squared x. This one's a little bit tricky because I can't really divide this out. All right. But one thing I can do is when I look at the sine squared x, I can convert that into maybe the cos because it'll be the same. So 1, because sine squared x is the same thing as 1 minus cos squared. So I can do that. And then 1 minus cos squared, that's like a difference of squares, right? So you can write it as 1 minus cos x bracket 1 plus cos x. Now I can cancel out the 1 plus cos x because I have it, or 1 minus cos x, I have them on the bottom and I have them on the top, multiplying each other. So I can cancel out. And I'm just left with 1 plus cos x. Okay, that looks like that is all the examples. Okay, let me just see here. What's the next lesson? Here is the worksheets. Let me go to the front page, just making sure cover the agenda. Understanding angles and identities and special triangles. Okay, so I believe we did that. Let me go back to here. Yeah, we're done with that. So you guys can work on the worksheets for today. Again, make sure you hand in. Someone's coming in now. It's at the end. Okay, maybe they got kicked out accidentally. Make sure you hand in your unit test. The X unit test 3. Okay. Make sure you handed it in. 11:59 p.m. is due. There is a quiz. Let me see if the quiz is showing. I gotta just double check. Yeah, quiz is showing here. Okay. There's a quiz for tomorrow on the 18th. Okay. Also too, before I even do that, let me close that. I have to make sure, give me a sec. I have to make sure the quiz for your your midterm confirmation is open, so you can see it. Okay, so let me do that again. Let me share my screen again with you guys, so that way you can see what I just did. Sorry. So, and I'm going to look at it from a student point of view. So here's day 10. So you need to do this. Confirm. You got to click on this that you've seen your marks. Okay, you've seen your marks. You got to click on it and fill it out by 1 p.m. Okay. Your marks will be released on July 18th. And again, if you want to drop the course, you got to do it before next July 25th. I think July 25th is next week sometime. Okay. What else? Here's a course withdrawal form. If you do decide to drop the course, it's right here. Okay. I can do that. And I think that is it. So to make sure, you got to make sure you fill this out. This Brightspace quiz, it's just to show, it's just questions based on your midterm mark that you've seen it. Okay, you've seen it, fill this out. Okay. I don't really have anything else for you guys today. I need you guys to work on what you need to do, which is the main thing is your Unit 3 test. Okay, so I will let you go. Okay, have a great rest of the day. I will post this in the Brightspace classroom. Thank you. I'm gonna stop recording now.